Hello everyone. The title of the talk is Laser Technology and Applications. I am Dr. Subhendu Mondal from Holdia Institute of Technology. And this topic comes under the engineering physics course. In this lecture, some figures will be shown, and I used to declare that some of the figures are taken from online resources. So let's start that topic. We know that we use laser every day, directly or indirectly, and everyone do so. So when you go for printing a page, there we use laser in a laser printer, as well as using a laser pointer, we can present a presentation, or we can use such a small little laser for aligning instruments, and we can use in various ways, as well as we know that laser has enormous applications in the industry. They are used for manufacturing of advanced materials, and it is used in advanced material industry, as well as laser is used in medicine, that we know, for various medical treatment purpose. So these are the few known applications. We have enormous applications like in research or in defense. There are enormous applications of lasers. So what properties of laser make it possible? The laser has been truly one of the greatest inventions in 20th century. The basic operating principles of laser were put by Charles Towns and Arthur Scalo from the Bell Telephone Laboratories in 1958. And the first actual laser was demonstrated in 1960 by Mayman. Lasers have found a variety of uses in electronics, computer hardware, medicine, industry, military, research, and development. And so what makes the laser a special light source? Of course, laser is a special kind of light source that emits coherent photons. And such coherent beam of electromagnetic energy, all waves have the same frequency and phase. So these two properties, coherent and equiphasal electromagnetic waves, makes the laser special. So in this lecture, we will present first the importance of the laser, and we will see that laser is used in everywhere, and then we will introduce about the working principle of the laser. Then we will know that what is the structure of the laser, and it will define the active medium, pumping system, and resonator. And then we will know that the relation between Einstein's coefficients, basically they are the relation between the various transitions, optical transitions, and what are the various types of laser are there, we will discuss. And then at the end we will we will discuss the applications of the laser in various fields. So, what makes the laser special? So, laser is monochromatic. It means that the laser beam consists of truly one color or one wavelength. That is, the light coming out from the laser, it is of single wavelength. And coherence, so it means that the individual waves of light are moving precisely together through time and space. So that's why the laser light is highly coherent. And directionality, so laser has the laser beam is well collimated and travels long distance with a very little spread, and brightness is very high. So the radiance of laser is an important factor. It is defined as the power emitted per unit surface area per unit solid angle. Principle of laser action. So, in order to know the in which principle laser acts, we need to know first about the basic processes. They are absorption, spontaneous emission, stimulated emission, and population inversion. So, in case of absorption, when an incoming photon excites the system from a lower energy state into a higher energy state, the atom becomes excited. And this occurs when a photon strikes an atom with just exactly the proper energy to induce an electronic transition between the two energy states. And here you see in the first figure, the photon is exciting in this atom from E1 state to E2 state. And after that, the electron is coming, by absorbing this photon, the electron is coming to the upper excited level. So what happened next? So after absorption of a photon or electromagnetic radiation, the electron staying in the higher energy state will come down on its own to the lower energy state, and the photon is emitted with an energy equal to the energy difference between the two states. So here the lifetime of the electron in the excited state will depend on according to the Heisenberg's uncertainty principle. And when the electron jumps down spontaneously from the higher excited state to ground state, it will emit a photon, and that's why this emission process is called spontaneous emission process. And stimulated emission is the process. So, in the after absorption of a photon by an electron in an atom, we know that according to spontaneous emission, it will come down to the lower energy state. But what will happen if an electromagnetic wave or photon strike before it goes down to the lower energy level? So in that case, the incident photon will stimulate to make transition from higher excited state to ground state. And such emission causes emission of two photons with same phase and frequency, efficiently increasing the number of photons, leading to amplification of light. In this fundamental process, we are able to see that we are certainly amplifying the number of photons, and that's why this fundamental process is crucial behind the operation of a laser. So here we see when electron is in E1 state, so if an external photon comes in, so it will stimulate the electron in the excited state, and then during jumping down to the E0 state, so they will emit photon of energy h nu, exactly the energy difference between the E1 and E0 state, that is equal to h nu. And we are able to see that we can get two photons of exactly same wavelength, and they will come in the same phase. So we can say that if stimulated emission, in the stimulated emission, we can have the two photons of the same wavelength. So monochromatic, they are in the monochromatic in nature, and they will have the constant phase relation. And so that fundamental principle acts behind the operation of the laser. Now the other next condition. So if you wish to, so we have seen that using stimulated emission, we can have the amplification of photons. But if you wish to amplify further, so another requirement is that population inversion. Another condition is required, that is population inversion. So generally we know that the number of electron states in a higher number in the ground state. So here you see that in the figure in the E1, the number of electrons are larger than the number of electrons in the E2 state. Now, the population inversion is a condition in which more atoms in a system are in excited state than in ground state. So if we can bring the larger number of electrons in the excited state, then such situation is called population inversion, and it is necessary condition for laser to function, so that there are enough excited atoms and that can be stimulated to emit more photons, and we will have the huge amplification. So to achieve such non-equilibrium condition, an indirect method of populating the excited state must be used, which is done using a 3-level or 4-level quantum system. So what is the basic structure of laser? So we know in this condition of population inversion, so we have to have the system where we can make the population inversion, and we also have to have that the excited state must be metastable state. So if the lifetime of the excited state is larger, then we can have it will be easy to engineer the excited state atoms, and therefore we need a suitable medium or quantum system that can behave or that can behave to make population inversion, and we will have the metastable state in that quantum systems. So that can be an atom or molecule or a plasma state medium. So the first crucial requirement is that suitable active medium for lasering action. The material that amplifying tries to light through stimulated emission, and this can be solid, liquid, gas, or semiconductor. And as you know, also we have to have the population inversion condition. So therefore, we need to have the pumping source. So the source that supplies the lasing medium with energy to amplify light, and this is called pumping source, and this is usually an electric current or light from different wavelength, and an optical resonator. It is a pair of mirrors uh, at either ends of the gain medium that reflect light back and forth, amplifying it each time. So here you can see we have the two mirrors, and will behave like a optical resonator. So one is a totally reflecting mirror, and another is partially reflecting mirror. So through the partially reflecting mirror, we get the laser beam output. So within these two mirrors, so when laser light reflected back and forth, we get we that photon interacts with the active medium, and we get the much more the excitation of the active medium system, and we will get the by doing so we amplify the photons.